Addition and subtraction of algebraic expression, a very interesting topic. But before we start picking examples and solving them, I would like to make this analogy, because if you're able to get that cleared out, it will make more sense to us if we start using alphabets and values. Imagine on one Saturday morning you want to wash, and this is your laundry basket. And in your laundry basket, you have different types of clothes in it, in the laundry basket. Normally, what do you do before you start washing? What we normally do is to sort the things out. So the clothing out, you put all the ones that are white at one side, and maybe you put the other colors at the other side, other colors. So normally that's what we do. And when it comes to the other colors as well, maybe we also have to separate them. Maybe the shirts from the trousers. That's what we normally do. So we put them into these categories before we even start washing them. So for the first division, all the whites go to one side, the other colors go to another side. Then with the other colors also, we might split them into shirts and trousers before we start washing. We actually do not mix the whites and the other colors and then just start washing like that. It doesn't work that way. We do not do that. So the same strategy or the same principle is applied in addition and subtraction of algebraic expression. So when it comes to washing, what we are trying to do is to put the things based on their similarities. So in this, we refer to them as like terms. They should be the same. So they should all be white. Then all the whites go to one side, they wash them together, then all the shirts and all the trousers go to one side. So keep this analogy in your mind as we proceed to addition and subtraction of algebraic expressions. So look at this equation, this algebraic expression. This algebraic expression actually has 6 terms. 1, 2, 3, 4, 5, 6. It has 6 separate terms. Now, I've also used different colors to represent each term. There is this in algebraic expression known as like terms. Like term basically refers to the terms that have the same variable. So if you have a term that has the same variable, they are like terms. So for example, in this algebraic expression, you have 2x squared here. The variable x squared in 2x squared is the same as the variable over here x squared in 5x squared. So that means 2x squared and 5x squared are like terms. The same thing applies to this one, 2x and 6x. So for you to know if particular terms are like terms or not, just check their variables. If the variables are the same, then you are dealing with like terms. If the variables are different, then you are dealing with unlike terms. So keep that in mind. So what that means is that 2x squared here is unlike to 2x over here because their variables are not the same. This is x squared and this is x. So this and this are like terms. 2x and 6x are like terms. 5ab and 3ab are also like terms. If you remember our laundry analogy, what we said is that you don't just mix all the clothes together and start washing. You first have to separate them. All the whites at one side, the other colors at the other side. And with the other colors also, you separate them. So when it comes to addition and subtraction of algebraic expression, one important thing to keep in mind is that before you proceed adding or subtracting them, you first have to group them according to their variables. In other words, group like terms together. So what does that mean? If you look at this next step, I've rearranged them 2x and 5x at one side, 2x squared and 5x squared at one side. Then we have 5ab and 3ab at another side, then 6x and 2x at another side. Now look at this. One thing you should take note is, as I am rearranging the numbers, I make sure that I carry the sign in front of the number, either being positive or negative. So I have 2x squared, so I move this entire 5x squared to this side. So I've grouped like them, so this is what I'm doing. Then the 5ab, I've moved the 3ab attached to it. Then the 6x, you'd realize that I've actually moved this entire negative 2x to this side. So I have grouped them. Now after you are done grouping like terms, what you have to do is to just add the coefficients. So for this x squared, the coefficient is 2, and this one, the coefficient is 5. For this, the coefficient is 5, and this is 3. This is 6, and this is 2. So you either add or subtract the coefficient. So 2 plus 5 is 7, and 5 plus 3 is 8. 6 minus 2 is 4. So let's see what that ends up with. So let's see what that ends up to. So we have 7x squared, 8ab plus 4x. So basically this is the entire or the whole thing when it comes to addition and subtraction of algebraic expression. As simple as that. I think at this point you are saying in your mind, oh please just end the lesson, do not continue, because I think I've gotten it right. Yes, I know at this point, no matter the question I bring to you, you should be able to solve it with ease. Now let's pick some more examples and see. I know you've mastered it, but let's pick some few examples. So the first example I have here is 7x plus 3y minus 4 minus 5x plus 2y minus 3. Let me write it out. So first things first, let's group like terms. 7x, let's write this 7x here. Let's try to look for another one that is x. This is y, this is 4, and this is x. So we have 5x. So remember, you have to bring the minus. So minus 5x. So we are done with the x. So now let's move to y. So this is plus 3y. So plus 3y. Let's see if we have another y in there. This is another y, 2y. We are done with the y. So what do we have? We have negative 4. So minus 4 and minus 3. Oh, so simple. 7x minus 5x is more like 7 minus 5. 7 minus 5 is 2. Then we bring the variable attached to the 2. So 2x. 3y plus 2y is the same as 3 plus 2, and that should give us 5y. Minus 4 minus 3 is minus 7. So at this point, we can't go further. So this brings us to the end of this question. As simple as that. Our next question will be 6x squared y cubed minus 5x exponent 5y squared plus 4x squared y cubed minus 9x exponent 5y squared minus 2x squared y cubed. Let's write it out and see. So we have this. Good, so a very lengthy one, of course, but it will follow the same strategy. So simple. So let's start from this side. So let's write 6x squared y cube. Let's see if we find x squared y cube again. X squared y cube. This is x exponent 5. X squared y cube. Good. So we have to bring this to this. So we have plus 4x squared y cube. Are we done? X squared y cube. Another x squared y cube. That is 2x squared y cube. Oh, so simple. We are done with the x squared y cubes. So now let's come back to x exponent 5y squared. So the first term here is negative 5x squared y. Negative 5x exponent 5y squared. So negative 5x to the 5th power y to the 2nd power. So I think, are we done? No, we have another one here, 9x exponent 5y squared. But that one is minus 9. So minus 9x exponent 5 y exponent 2. Good. So easy. Now what do? We realize that these terms, this, and this are actually like terms. So you have to add and subtract their coefficients. So let's look at this. 6 plus 4 minus 2. Basically, that's what you have to do. So we have to do 6 plus 4 minus 2. So that's the step we have to actually follow. So let's do that and see. 6 plus 4 is 10, minus 2 is 8. So what that means is that we have 8x squared y cube. So we are done handling this side. Now let's move to this. X exponent 5y squared. We have negative 5 and negative 9. Negative 5, negative 9 gives us negative 14. Minus 5 minus 9 is minus 14. Minus 14 x exponent 5 y exponent 2. So straightforward. So this is the end of the simplification of this question, this algebraic expression. Let's pick our last example. Subtract 6y squared minus 9xy plus 3x squared plus 3 from 4x squared minus 5xy plus 8y. So we are subtracting this from this. So that's what we are doing. So let's write this first. Let's write this side first. So now that our question is written out in this form, what you just have to do, the reason why I've put this into brackets is for this subtraction sign to operate on each of the term in this second algebraic expression. That's why I put all of it into brackets. So let me just remove this bracket and then use this negative to operate on it. So what that means is that when I remove the brackets for this one, this is more like there's 1 here, and 1 is going to multiply everything here. So it's the same thing as x squared minus 5xy plus 8y squared. And here is where the thing becomes interesting. Negative 1 times 6y. This 6 is positive, but it's not shown. So negative 1 times positive 6 will give us negative 6y squared. And negative times negative will give us positive. So positive 9xy. Negative times positive will give us negative 3x. And negative 1 times positive 3 will give us negative 3. Good. So this is how it becomes. Then now we proceed with our next steps, grouping like terms. So let's start from 4x squared. So 4x squared. Let's look for another x squared. Oh, I think we do not have an x squared again, so that means that is all. Oh, I think I am missing out something. This is 3x squared over here. I think I didn't bring it here. Sorry. Good. So that means there's another x squared somewhere. So we have minus 3x squared. Good. So we are done with the x squares. Let's move to xy's. The first xy we have is negative 5xy. Is that all? Let's look for it. Here you are. So that is 9xy is positive. Positive 9xy. Do you have another xy somewhere? No, that's all. Yeah, that's all. Now let's move back to y squared. The first y squared is positive 8y squared. Is that all? Just close to it, we have 6y squared. Let's double check to be sure you have not made mistake. Let's count the number of terms in the original one. 1, 2, 3, 4, 5, 6, 7. And we have 1, 2, 3, 4, 5, 6. So we are left with adding the negative 3. And that will mean we have actually not made any mistakes. So now let's add and subtract where necessary. Yes, positive 4x squared minus 3x squared. So 4 minus 3 is 1. So this one evaluates to x squared. So we are done with this side. Now we have negative 5x squared plus 9x squared. So negative 5 plus 9. Negative 5 plus 9 is the same as 9 minus 5. And 9 minus 5 is 4. Yes. So this side will be positive 4xy. Positive 4xy. I think we are done with this and these two. Now let's move to the y squared. 8y squared minus 6y squared. Let's just subtract 6 from 8. So we have 8 minus 6 is 2. Positive 2. Now let's bring the variable y squared. Oh, lonely. The lonely 3. It has no friend. So minus 3. Good. Can we perform any other operation? I think we've gotten to the end. This is a dead end. We can't continue again. So this is the end of this evaluation. We are supposed to subtract this from this end. We have landed here. That is x squared plus 4xy plus 2y squared minus 3. So that is it. Good. You see how interesting it is when it comes to addition and subtraction of algebraic expression. And it is very, very simple. Our usual subtraction and addition that we've been doing. Let me just give you this question. You try on your own and you write your answer in the comment section. Here is the question. Good. So simplify this algebraic expression. Simplify it and leave your answer in the comment section. 7x plus 3y minus 4 minus 5x plus 2y minus 3. So I'll be so happy to see your answers in the comment section. Now in our next video, we'll still be on addition and subtraction of algebraic expression, but this time around there are fractions involved. So addition and subtraction of fractional terms in algebraic expression. See you next time.